Today we shall learn how to form the equation of a straight line, which is y equals to mx plus c. This equation of a straight line is also called the gradients-intercepts form. First, let's recap. What is the equation of this horizontal line here? Now you notice that this horizontal line cuts the y-axis at 3. Yes, the equation is y equals to 3. Next, what is the equation of this x-axis here? You're right, it is y equals to 0. Now let's look at this vertical line here. What is the equation? Since it's cut the x-axis at -1, the equation is simply x equals to -1. What about the y-axis now? Yes, it is x equals to 0. What happens if the line is a diagonal line? Let's say the line cuts the y-axis at c here, and the gradient is equals to m. What is the coordinates of these points here? Yes, we will always read the x coordinate first, then the y, and hence it is 0, c. And let's say we are given another point here, x, y. We shall now derive the formula of this diagonal line here. As you know, the gradients formula can be given by y1 minus y2 over x1 minus x2. Now we shall sub in the values from the diagram here, whereby the gradient is equals to m. And we have two pairs of coordinates, xy and 0, c. Substituting into the right hand side, we will have y minus c over x minus 0. We shall now do a bit of algebraic manipulation by doing a cross multiplication. On the left hand side we will have mx, and on the right hand side we will have y minus c. Now we shall proceed to add c on both sides, and we will end up with mx plus c equals to y. Rewriting y on the left hand side will result in y equals to mx plus c. And hence the equation of this diagonal line here is given by y equals to mx plus c. And what is m? And what is c? Well, m is actually the gradients as seen from this diagram here. And c is the, yes, y-intercepts. Now the xy here represents the coordinates of any points on the straight line, which means that there will be a value of x here with a corresponding value of y which lies on the straight line. Now this will become more apparent in the examples later on, and hence this formula is called the gradients-intercept form, due to the fact that you can simply find the gradients and the y-intercepts when the equation is in this form. One last thing to take note is that y must have a coefficient of 1. Now let's look at this example here. What is the gradients and y-intercepts of the linear graph y equals to -3x plus 5? And hence later we will learn how to sketch the graph. Can you spot the gradients from the equation here? Now the first thing to check is whether this equation is in the gradients-intercept form. Since y has a coefficient of 1, and this is in the form y equals to mx plus c, we can simply tell that the gradient is equals to, yes, it is equals to -3, as seen from the coefficient of x here. What is the y-intercept then? Yes, it is simply plus 5. To sketch the graph, we shall now do a negative gradient sloping graph which cuts the y-axis at 5. And hence it will look like this. It cuts the y-axis at 0, 5, and it is downward sloping. Next, we shall look at another example here. Now, what is the gradient and y-intercepts of the following linear graph? Y equals to 2x minus 7. Again, check that it is already in the form of y equals to mx plus c. Yes, the gradient is equals to +2, and the y-intercept is simply -7. Therefore, it will cut the y-axis at -7, and it will be, yes, it will be upward sloping. We shall now look at yet another example. 3x plus 2y equals to 6. Is this in the form of y equals to mx plus c? No, it isn't. Therefore, we have to change it to that form by making y the subject. In order to do so, we will subtract 3x on both sides. And hence, on the left-hand side, we will have 2y. And on the right-hand side, we will have negative 3x plus 6. You notice that I put negative 3x in front of 6 here. This is because I want to make it y equals to mx plus c. Next, to make y the subject, I simply have to divide by 2 for each term. And we will have y equals to negative 3 over 2x plus 3. Now, can you tell what is the gradients of this equation here? Yes, it is negative 3 over 2. And what is the y-intercept? Yes, it is positive 3. In order to sketch the graph, I simply have to draw a downward sloping graph that cuts the y-axis at. We shall now look at a final example here, which asks us to find the coordinates of points A, B, and C in the equation 3y minus 2x equals to 6. Now, please remember to record these notes here. This is very important to know that to find a coordinate on the x-axis, we will always let y to be 0. And to find the coordinates on the y-axis, we will always let x to be 0. Now, the coordinates of A can be given by x0. By substituting the values of x as x and the value of y as 0, we will get 3 multiplied by 0 minus 2x equals to 6. And hence we will have negative 2x equals to 6. We shall now divide both sides by negative 2 and we will have x equals to negative 3. Therefore, the coordinates of A is negative 3, 0. To find the coordinates of B, we shall now let the coordinates of B be 0, y. And we will substitute this value into the equation here. And we will get 3y minus 2 multiplied by 0 equals to 6. And therefore, 3y equals to 6. And finally, y equals to 2. And the coordinates of B will be 0, 2. To find the coordinates of C, we shall now substitute in the values 3p into the equation here. The values of x will be, yes, it will be equals to 3, and the value of y will be equals to p. We will get 3p minus 2 multiplied by 3 equals to 6. Now do remember to substitute in the correct values for x and for y at the correct place. Simplifying, we will get 3p minus 6 equals to 6. Adding 6 on both sides, we will have 3p equals to 12. And finally, we will get p equals to 4 by dividing both sides by 3. And the coordinates of point C will be 3, 4, as shown here. Do look at the next video for more examples on equation of a straight line. And do review your notes again because there is quite a number of new things that you learn in this lesson.